Mr. Johnson, how you doing today?
Good enough, I suppose.
Good. Got any hot date with the wife on Wednesday?
Nope.
You're not gonna cook her dinner or nothing?
Well, I cooked dinner on Saturday, so maybe that counts.
Saturday's a bit late.
I better start figuring something out.
Yeah. You get her a box of chocolates, or does she like chocolate?
We don't buy candy too much.
What do y'all buy?
Groceries.
Okay, well, do you buy like gifts right
Not that much, no.
Weird.
Mr. Tarbutt, like I admitted to you
Good job.
All right, guys. First off, I want to remind you guys that we have our Chapter 5 test coming up on Friday. And as you should have heard in advisory, we've got a slightly different schedule on Wednesday.
So I will still see you on Wednesday, but it's only like 80 minutes instead of 90 minutes or whatever we currently have.
So I've got two more things that I feel like is good practice that will help move you in the right direction today, as well as giving you a chance to ask questions from your test review that I asked you to finish up. So, number 88 was your test review, and over 3 different class periods, we have already done the 3 FRQs on the front. So, I guess you can ask about those if you'd like to, but my main focus would be on the back page. Because we had looked at number 8 as a group, and some of this stuff we've not talked about since the first week or two back in January, but everything we've done since you came back, actually some of the stuff we even did back in December,
The Riemann sums, the trapezoidal sums,
that was all part of Chapter 5 too. So, I'm going to start off with your questions on that. I will give you one more opportunity to ask questions on that on Wednesday, so if you need to ask more questions on Wednesday, that's fine. But as someone's not or as anyone's asking a question that you don't need help with, I'd ask that you go ahead and start on the circuit first. Please do the circuit first.
it's a very short one. 12 questions total.
And it's focused around fundamental theorem of calculus. So I don't think that one will take you the whole time, but as you finish that up, last use of practice, short of where it just kind of pops up here and there and like practice FRQs and stuff like that the rest of the year, would be use of worksheet 2. You'd already done worksheet 1, so
Again, no such thing as too much practice there. So if you feel like you've got that skill down, it's great, but you can focus on
your speed there. Okay. Okay, so for those of you that have some questions from number 88, your test review, which questions
would you like me to discuss with you?
Yeah.
What about questions not on 80? Like on the like if I have a question on like a different person.
I'm on 88 right now. That's not going to help anybody but you, so.
So just out.
Or during advisory. Also, it's a good idea since you guys can still make changes for your prime time this week. If you have not come by and looked at your 5.1 through 5.4 test to see which questions you missed, that might be beneficial to help you to prepare for Friday's test. Some of the same content will be on it. So, can't come see me on Wednesday because of testing, but Tuesday, Thursday would both be good. I guess even Friday technically because advisory would be before your test. So. Nothing from number 88, the back page.
Can you go over number 10?
Number 10? Sure. Okay, so if you did not need help with 10, please spend the next couple minutes doing maybe the first question or two. from the circuit.
Just make sure.
All right, question number 10. Ask us to integrate here. So again, it's fine to not think that integration is easy or that it's more difficult than derivatives, but there should only be a couple methods for integrating. Either it matches something we have memorized. This does not look like something we have memorized. It is just undoing the power rule, which unfortunately this is not. And then assuming that you can't rearrange things with fraction rules and exponents and all that kind of stuff, really your only option after that is u substitution. So I'm going to guess that x to the 4/3 minus 1 is u, since it's trapped under this fifth power. Which is looking pretty good because this is like x to the 1/3 and I have an x to the 1/3. So I'm pretty sure u substitution is going to work out here. So in place of all of this, I'll say u to the 5th. But to replace x to the 1/3 dx, I don't know what x to the 1/3 dx is yet. So my advice was to write that down underneath it. Think about what you need to do to this. I need to multiply it by 3 and divide it by 4. Multiply by 3, divide by 4. Just do the same thing to the other side. And now, after I've done that u substitution, now it looks like I'm just undoing power rule. Raise the power by 1. Divide by the new power. And plug u back in. And I'll go ahead and reduce this. Looks like we should end up with 1/8 times x to the 4/3 minus 1 to the 6th power plus c. So u substitution was the only way to go about that one. Okay, is your question about this? Okay, what's your question?
Do we get a lot of points off or do we get points off if we forget the C?
If you forget C, well, it's pretty hard to forget C in a multiple choice question because all the choices should have plus C. I don't think like half the choices have plus C and half of them don't. I don't think I've ever seen that. But even if they did, if you're looking at all the choices, I think you're going to remember plus C when some of them has plus C there. On a FRQ, there are times where a part of an FRQ might be worth 3 or 4 points, and it will say something like, if they forget plus C, the max they can earn is 1 point. So it can like limit how many points you can earn in a section, even if your answer is correct and you accidentally get to the answer or something. So yeah, forgetting the plus C is a very common mistake, but okay, did anybody have anything specific about question 10 before I move it away? Okay, what else you got from 88 that I can help with? Okay, well, I will save a few minutes on Wednesday to give you one more chance.
So if within your studying you decide that there was something you should have asked, you should have an opportunity to. Now, I'm not going to budget maybe half a class or anything when you guys have already had a chance to ask questions, but I will budget a few minutes at least. So. All right. So the next focus, the next thing I'd like you to do is work your way through the circuit. And again, there's not a lot of questions there, but you do need to make sure you read the directions, of course. Eventually, it'll talk about, well, in the directions it talks about a function h, and eventually around question 10 or so, maybe a little bit sooner than that, it starts referring to h. So h, the function h of t is in the directions, so you'll need to see that. And at the top of that circuit, there's a graph for f of x. So sometimes when it's referring to f of x, you're going to need to use that graph. So I will be going around helping and making sure that everyone is finished and comfortable with the circuit. But as you finish the circuit, go ahead and move on to the U substitution worksheet 2. More of that you get done in class, the less homework you will have, if you have any. Because a lot of you should be able to finish that in class too. But if you're still struggling through U substitution, you may not have full class time. So I'm gonna finish putting these homework grades in, and then I'll come around and help you guys out with the circuit. So give me just a couple minutes to do that, please. Oh, I didn't ask y'all to turn in any homework this time. And as I've been saying, remember I've been telling you guys this chapter 5 is the hardest part of the semester for almost everybody. So please, please, please do your best to prepare for the test. I promise it gets a little bit easier after that. So. All right, if you've tried questions 1 or 2 on the circuit and need help, let me come over and help.
Where's your student? Where's your PJs? You go, no problem? That's us. Should. Everybody's giving pepper out here. With pep.
U substitution is about integration, so that's not going to help you when you change the derivative of an integral.
That was really bad.
You
just kept writing the wrong.
Yeah, because inverse because we call it the just can't flip the inverse. Just plug in x. And then we plug in that's only for x. So then you start with 16. This function. Yeah.
If the bottoms are constant, then this just gets the plug into what's. Negative to the right side, then you're also taking the derivative of the right side, this is but understanding why we don't do that offer more questions on and some other
So then you just do 1 to -2, and then find out as 1, plug it into 1, 0, and then have them -2 as 1. Oh, yeah.
Oh, I was just gonna do area.
Oh, that is area.
Square root of 1 plus x.
Oh, wait, hold on. I see. Yeah, you're right.
And that's only because x is a constant. And then you went
What is that?
Sometimes this is just constant, this is that part integrated. Well, you mean, oh, yeah.
Yes. I think so.
Wait, what is E? Inverse.
Wait, what did you plug 5 into and subtract that? You still have to plug in 1, 2, 3, or 4, but it kind of
We're
works.
gonna help you if you're starting on questions 1, 2, 3, or 4.
I don't know, I could be wrong.
We're supposed to do this now when I had to music afterwards.
The position. What is that?
This is 16.
Okay, what's 16 to the 3 halves?
Was it 16?
Okay, well, what's 16 to the 1 half?
Shoot. 4.
Right, because it's like square root.
So 4 times 3.
Wait, no, short is the third. So 4 times 4 would be 16.
Tree of these integration, so you
Yes,
just
they
like
expect you to do fractions. You can do them in two parts.
except you don't actually have to take
So yeah, my timer was
So like
more
two parts,
than
you can square root first time.
I'm just gonna act like that's how it works.
Which one did you put for the outer 6?
He had
One number 5.
Wait, can I see?
Oh,
My
yeah.
professor keeps getting
Yeah, I had to without doing that. I just got it. I was just like, yeah.
No, I know.
If we have to do the same 5, that would
I think we're watching the same program.
So we do that.
How do you take these?
Oh, that's true. That actually
Two
would
5 over 5.
Yeah, no, I think it was because it's just like an end.
Derive both sides, so we could get rid of the integration.
Yes.
Oh, yeah, just
If it doesn't work,
Oh, no, yeah, that is because we have constant 2. So when we have a constant 2, you only just take the 2. Oh, yeah. That's second. Yeah. It's only when both of them are constants that you have to do that.
oh, I see. I was thinking of the wrong one.
Those 3.
Yeah. So really, it's just 3. Because they plugged in.
Because you use a 0 and 1, I just changed beta to X. You don't have to
Doesn't matter. It's just X.
I just don't like it.
Because I'm signed. First time.
Wait, is this
Yeah. You guys. Oh wait,
the derivative of anything?
I thought that was
It's like 79 or something.
so this is just.
Are we gonna actually do the substitution zero? Because it's secant squared. Yeah. So.
I don't think this is.
You always see it when it's secant.
Yeah, that's right.
No way. I think this is
No, same.
the first one. This is the fun one.
And so is this one.
We have
So we're in.
function SAT.
So you don't get it.
Equals S0
Okay,
plus.
so you're trying to find S that's pi over 4, right? And here's
So like
S.
so we're doing like this.
So you should be taking the derivative of any of this stuff.
Should still be.
So I disagree with your answer. Like, what can you take the derivative of to get secant squared? Right, so this should just be tangent to pi over 4. Well, tangent x is tangent phase. But also 8 over 5.
Are you worried about your test?
2 over square. Yeah, there's the negative 2 squared. Yes.
I feel like it's not really too difficult if you really.
Yes. 4 times 2. 4 2. Yeah.
make sure I wrote that on there, like the 8 over 5. Check out there. Antiderivative US 2 is probably 8 over 5.
Yeah, because it's a constant, right? So it's constant.
Yeah, well, they give you the starting value. Plug that in. And then we need to do the antiderivative of that. You can always try to use it if you want to, but it's not going to help you.
Yeah, it would.
It looks messy, but it's not a hard antiderivative. Like, if this 8 over pi is just a constant, right? Yes. So let me give you a different constant this time. That was 2. What would the antiderivative 2 be?
So it's 2x.
Or 2 beta. 8 over pi beta. Yes.
Just one.
And then what can you take the derivative of to get secant squared?
Oh, that's what I was trying.
So one was I'm doing power rule. It just more complicated than one was I'm doing reasons. But you can always try use substitution if you want.
Yeah, I was gonna
on a
try
question
use
like that. It's not going to help you, so you're wasting your time.
Taking the double
Oh, somehow I do this.
I like how we remembered this last week. I forgot.
It's screwed because I was doing derivative all of last semester, so then I was so used to it. So now we have this.
Negative 6.
Yeah, I'm just gonna wait till
Plus
I see
2.
you explain it to me. But
Well, that's the
Actually,
So you got S, take the derivative of it.
right?
Well, not exactly.
The math was actually.
So you take the derivative of an integral where the bottom is constant. Let's plug this in everywhere there's an x.
that's a 0.
So it says cosine x, cosine negative 6 plus. Well, very easy.
Negative 0 is 0. So it's negative 0.
It's not even close.
Because it's negative 6 plus.
Oh, but 10 and 0?
That's the part you need to understand, to get the derivative of that type.
Okay, so are you just.
Well, 10 over 4 is, yeah, it's like perfectly 45 degrees, which means that sine and cosine are the same. So it's just 1. Oh.
Oh, it's just prime.
It would be 0 though.
Oh,
right
0
there.
minus. Because we have to do now the bottom, the 0. Because we have the, that's why I said
Negative 3, okay.
so it's negative, because those other two is just
Place your t, you need a t here. Place the t, you need to 3 pi over 2. And in place of that, I mean, 3 pi over 2. So when you simplify, it goes down to 3. But you need to.
So we plug it in.
Cosine of 3 pi over 2.
And then we take the derivative.
No, the derivative.
Because we're doing double. So we just plug in t in. And then after that we take the derivative.
So it's just 1 over t minus 1.
That's the x 1 over
All of that.
Which makes me feel better. A lot. I was gonna do it. I was gonna do it. You're gonna do yours.
Alright, so right now we have
Yeah, but what you do is you take the double derivative of an integral. So this one of the derivatives cancel out and you have to take the derivative.
Yeah, I'm skipping practice.
Double derivative.
And it's
Okay, I think you have this. So find W prime. Which is that?
So the fundamental rule of calculus says that they cancel out.
But we're finding no. No, I'm tweaking. I'm an idiot. Oh, wait, okay, so then it's just get rid of that. Yeah. So yeah, so W prime of T. Yes.
This happens so
Oh yeah.
remember.
So yeah, then you just take the charge. I mean, it feels more complicated. It's just 1 over T multiplied.
Yeah, there's like half. There's like
And you plug it in. Yeah.
oh yeah, the flashback. So, I don't think I think it's like half of your badge off.
I thought we were going to have it yesterday. And I was seeing it
Yeah.
I was thinking about it. It's like
No, I think no, he had a wife and then he left his wife.
You don't think where it's like
I don't know why though. That's why I was thinking.
yeah. Well, no.
I really like
Are you on 6?
Oh, I see.
You just plug in.
On 6, did you use substitution?
Which would mean, yeah, negative. Negative
I feel like
one
it's
squared.
something that.
What's the antiderivative?
It's just something that we
You can't have one as it's the fundamental rule.
Wait, if it's negative all the time, or in the bottom,
But no, chain rule doesn't. You're on 8, so you obviously.
what says negative pi?
It's just down to that because now you have a negative code before would be instead of
It is
going
about
up like this, it goes down like this.
Okay.
So then you have like cosine, like cosine is negative 2 pi over 2. It's negative.
Well, yes,
Because-
but then then it would be
Cancel
negative
out
squared.
one. The thing is, if it's 1, it's 1 plus 1 is 2, and then 2 over 2 is 1. We already have an answer that's 1 right here.
Give me just a second though. I need to send this to the. Okay guys, in just a second I want to talk about question 8 because I've had like 4 groups in a row ask about that one. And everyone's having the same problem. So give me a second to get it on my screen. And then I'll make a video for it so that you can watch it again later if you feel like you need to.
Isn't it just zero?
Okay, so if you are not to question 8 yet, I will tell you that this one is number 8. And again, everyone's having a very common mistake here. Also, just, I don't know, maybe it makes you feel a little bit better, but I was doing this circuit on Friday just because I like to refresh myself before I give it to y'all. And I had made the same mistake that all the groups are making. So, for this question, if you want to take the derivative of an integral where the bottom's a constant, you know these two basically mean like they're canceling out, not exactly, except that tangent gets placed everywhere there's a variable. So you guys are doing a good job with that part. But there was one other part of the second fundamental theorem. There could be a chain rule piece. if the derivative of the upper bound is not 1, you have to multiply by the derivative of that upper bound. Y'all remember that? Okay. Well, that's part of the second fundamental theorem. So I would circle this one or put a star by this one, because this, I'd say when this shows up on the AP exam, I say it's 50-50. 50-50 whether it's going to have chain rule or not, like this one did. I guess this would be T. So that is what this would equal, and then if you plug in, try to solve it for negative pi over 4. Let's see, at negative pi over 4, tangent is -1. You square that, you get 1. So a lot of people were getting 1 for an answer, but you should have already used the block that said 1. But if you remember the chain rule part, at negative pi over 4, cosine would be square root of 2 over 2. So secant would be the reciprocal of that. And then if you rationalize that to make it look nicer, that would be square root of 2. But if you square root of 2, you just get 2. So in the end, you end up with 4 over 2, which comes out to be 2. Half of knowing the second fundamental theorem of calculus is making sure that you check for chain rule on that part. And since you guys have all done this, again, I still suggest you come and look at your last test. But one of your last test questions was like that. And it had the chain rule step. And one of the answers, probably the most picked incorrect answers, didn't have the chain rule part on there. So, could have been a really easy question on the last test, but if you didn't think of the chain rule part, then you didn't get it right. So.
Sure. So this is good for starting value. I don't know what this says.
Finding S.
Okay. This says S of pi over 4. Okay, then that should be equal.
Yeah, and this, I didn't know what space would equal.
So starting value, and then you're trying to do the antiderivative here. So the derivative of tangent is secant squared, so that was good. But this I disagree with. The derivative of pi over 8 is not, or 8 is not pi over 8 over pi.
So secant is like one.
Let me give you a different concept.
So cosine is 2 over the square root
The
of 2.
antiderivative of 3.
And then if you take that and you flip it, it's 2 to the square root of 2. The thing is, you don't like having radians bottom
Well,
of your thing.
that's
So
a constant.
you multiply the square root of 2.
So it is
So you have 2 square root of 2.
Pi to -1.
And the 2's cancel out, you have square root of 2.
This is
And
also
then
a
you have to square that
constant.
because it's secant
So it's
squared.
going to integrate the same way.
And then so square root of 2 squared.
I don't know, instead of an x, it would have a
You have
beta.
1 times 2, you get 2.
But it's the same idea. It's just, it's a messier
2
concept, but
over
it's
1 plus 1.
has a
So 2 over
similar
2.
antiderivative.
2 over 2 plus 2. It's just multiplying this by this. Bring that down, bring the t down. Yeah, so it's just after the t. So it's Number 10.
Are y'all on the same page?
Yeah.
I agree with that.
They were saying that to find each private
Prime is the same thing as F
Oh,
of
we're
T.
finding.
So we said that was F3, but that was already used as an answer.
I disagree with that. I got -2. So I think you're right there. What one did you get -2 on?
Yeah, 3, we got -2, so this one.
I'm not walking this way.
Are you continuing?
I'm not gonna graduate.
Wait, so that's.
Like, I heard other classes in high school some days.
Okay, so you plug in a 4 there. Okay, you chose to switch the bound and make it negative, that's fine. You didn't do the anti. You said integrate T, but then you didn't do that. The integrate T, it would be 1/2 T squared, and you just use T. You just start plugging in numbers in before you do the anti. That one should come out equal.
That's weird, because we had the same number 8 as everyone else. So we must have messed up this one too, or something else along the way.
Yeah, the ones, these circuits, some of these are just a little bit better than others, where if you make a real common mistake, that's still gonna answer, and then later on you figure out, wait, something's wrong because these questions are really, really thought through.
Because wouldn't it just be the
That's why I like to use them all.
area of.
Oh, yeah, that makes sense.
So number 3 would actually, yeah, X squared.
Wait, Trent, are you still at 6?
What was the hardest one?
So we're going to square. Well, the hardest one is
This is 3 down here.
That's what I'm saying. But like the tank one here is really bad.
Well, no, it should come full circle.
But the answer I got made sense.
So that means we probably only got like one other one.
Yes.
And then,
Or make it negative.
This is,
so then this one is 3.
Yeah, that was.
And then where does this go? Because if this goes, this might just go to the straight.
it could, let's see.
Also, this one should be 11.
Yeah, I think I remember. That was the only problem I had.
And the answer,
Wait,
You don't get a separate sheet of paper and you write things down like that, you know. That's
wait, so this one?
yeah, so then you just square it.
That's part of the stuff that you know that you use.
I signed up for Farmville tomorrow, so. I just had a question about the accumulation of Farmville.
This is actually 4.
So then,
Sorry.
right here.
Oh wait, I just realized. Yeah, okay, so this one has to be 12 then, because on number 9 it says the rest of the question is about each of them.
Oh, right.
So this one's also, so this one's 12. And we just so those were the 2 we got wrong.
Here, this one.
Maybe.
I'll do that in a second.
I'm gonna try to just catch up.
I'm gonna keep
rolling. Yeah.
Where did this come from? So add it into like the different.
Okay, so right here, you've got y of 2. Well, you really should get a y over 2. Okay, so in the next question, we want to know the rate that's changing.
Yeah, so then from
So
there,
we want to know the derivative of
because
this,
on the other number,
and then we're going to plug
Oh, so we messed up
So if I take the derivative of this function, the derivative of that.
Okay, so 4.
so then this goes number 1 and then the rest go on.
5 is number 1, and then, okay, that's how we do it.
So 11's the first bit.
One of these should get like
Oh, this one's just one.
Well, but we already got that.
adding.
12 is wrong. Whatever we did for 12. So.
No, RT is meter.
We have to get, for 12, we need to get negative 9.
Wait, is this actually 10 or is this?
No, that's, you can see.
So yeah, that is actually.
I was wrong at the start.
Okay, so you should write
Which
this
goes
down.
negative two.
You just plug in the-
Wi-Fi equals.
-2. And you just get,
You don't have to integrate for L, but it might help you see functions. Minus.
Oh yeah, because it's H and negative 2.
That's the H, so that's using the.
I was right.
But what we really want to do is Wi-Fi is 4. So I plugged in 4. into
That's
the-
actually. Yeah, you're right. That's.
Maybe that's what it is.
But why did I
So
also
I
add
put -2 then.
Okay.
Wait, no, but that's
that's
still only about 12.
No.
Because that's just 1 or minus 2.
No. You're just looking at the area under the curve.
Because H or negative 2 is just simply.
Oh wait, you're right. We have to use like Riemann on the sides or something.
Kinda. Well, sort of. Yeah. You're just splitting it into shapes.
Yeah.
And then get taken into it.
And also,
Riemann sides.
I forgot how we found the
What is this number?
critical number. Do I just have to
Simple numbers are when something equals 0.
That's the last one.
Well, what is it?
I think it's. I know, but I'm saying we're trying to say.
Oh, this says 90.
And then the other one's
If I said this,
Sure. You want to find it? So you can graph this in the calculator and it will be fairly and then let that convert into this function by that understands.
Oh.
oh yeah, I was also confused where we were plugging in. So we're just plugging in.
That's what you didn't do. You wrote a function that tells you how much things you have at this time. So if you want to know how much thing there is at time 0, it's like 0 is that function.
She's not terrible. I like these other things.
I think we legitimately just like remember, because I know it's fine, you need to find the variance of the curve from 1 to 2 on.
I think it's just like
From 1 to negative 2, correct?
So is it 2 plus half, or is it?
Well, but if you're going from 1 to negative 2, you're going right to left. So it's going to make it all negative.
That's what I was thinking.
Or if that bugs you, instead of 1 to negative 2 something, remember that you can switch these two if you want to. Negative 2 to 1.
And make the whole thing negative.
Right, just make the whole thing negative. Then you don't have to worry about the directions as much.
It's all the same. I feel like guys get it. I mean, girls get it. Oh, wait, you said you see it.
Oh, wait, yeah, I see it now.
I won't. So nobody was on Instagram, and so I got like 200 last night. Yeah. I think everybody just kind of hates Instagram because I think they use like for super. I kind of hate Instagram.
Okay.
It's why. Oh, I see. Or like you can buy stuff like on Facebook.
Well, the derivative. Okay. So that's not a good. If you make u be secant of 2x plus 1, what's the derivative?
I was like, okay, just say it like this.
Well, that's why it's hard for you to pick up.
That's something that we do.
The derivative of secant something is secant something cancels something.
Has been like acting really like want to pick up.
Yours would be secant of 2x plus 1. And then you got okay, wait. Then you could just replace. You can just call this integrating. Just integrating u.
It was mostly for like this future.
The du is exactly the whole problem, right? So how do you integrate the
He
u?
doesn't feel like he has to.
Well, actually, on this, you have a little bit. The derivative of secant is secant something tangent something, but you need to change all there. So you have a
He was so scared.
No, I'm scared.
yeah, because your derivative part should have the times too. So you still need to back to there. Because the derivative of the inside, your inside is 2x plus 1.
But I would like.
Restart the question. Erase it and restart with you guys. I gave you some hints. So try it from there. I'll help you to get started.
He misses like,
If you want to integrate.
I think so too. I think he's really not focusing on like what
Just
he's
rewrite it.
about like what's negative or what.
It's like 1 over x. Because if it's 1 over x, you write that as x to the minus 1.
What do you want to do?
Try to undo the power by 0. You raise the power by 1, that goes to 0. But then you also have to divide by 0, which doesn't.
Who's turn? Oh,
Ben, you need to get your throne.
I completely agree.
how many questions on the test? You don't
And if I
know.
go to California,
You wrote this test.
if I make it.
Can I see it real quick?
It's gonna have some questions like
Multiple choice then, right?
some of the multiple choice.
And how many effort keys? Like 2 or 3? Like 1 or 2?
1 or 2, like usual.
Can we cross one off?
Choices either 9 or 15, depending on if we grade it as a test or quiz, which doesn't make any difference. You also still doesn't grade, but that's 50 points.
Alright, can we cross out one of the effort keys or 7 or something? Can I be part of the voting committee?
Generally, if we do that, we're given 2 tougher FRQs in our case.
Oh,
So to cross someone out, that would give you some flexibility. If we give you just 1, it's one that we think is fair for everybody. And so it's 50-50.
could we get like one easy one instead of 2 tough ones?
No.
That's what you're saying. I think she has a question.
Well, so by having the derivative of this, now we get this and this.
There's a chance that's
Times that by your 1
Well,
half cancels it out.
it's gonna be a harder one if they let us cross it out.
But you need to memorize that,
Like,
that trick
if they
that
let us cross one out,
right?
because it's too hard for people. It's either two like mediocre ones or two.
But that would create or a negative feedback. So you've got a negative that balances that out. Chain rule would multiply by 2pi, plus your 2pi, so that was line 2. Your response? Sure. Why not? I can't think of any. It's just that if you try to do this in your head and you're not being instructed like that, you might get scared. And then if that's part A, you might find parts B and C might refer to A. And you can get some points on those when A is wrong, but if A is wrong, it makes things harder because you might be making the question harder.
So what I think is this is technically one.
Well, because last year we
You can pull that EX out to the right.
and then this year we had 90 and then now we have 100.
Serious? Okay, I'm not worried at all about this. I'm freaking out about this.
This is like cosine of the square root of x divided by the square root of x. And you now for the side. Your answer to that. You need to do this. You may not see the square root of x as if it's I'll be back.
I had trouble with head and how would I find derivative of I
Here's f of x, right? Well, remember derivative is just like slope. So you just need to do rise over run at x equals 1.
always forget about the fact that derivative is just slow.
Write that down somewhere and review it.
Yeah. And
That's the point of this practice, is to help identify what you don't remember well.
It's fun because I just know the graphs of 16. Well, it's worksheet 1 and 2. The first one goes 20, the second one goes 17. So that's right. I see. Yeah. Plus, they're all loops and questions, so I
Are you doing that? the question is,
See y'all think about that.
we should get the same.
I was gonna wait until he starts.
Oh, I just have to. So if you don't do you sub, you have to change.
Well, when you're in the pattern, that's what I was trying to figure
Where did this -3 come from? Where did the 3 come from? Oh, you just have to change
All right, you guys still have 40 minutes. So again, good chance you should not have any homework, but it's going to depend on how focused you stay.
For 7, it'd probably be easier to sort that distraction part first. Simplify. And which one?
Okay, that'll take a
Well, I don't know. I haven't worked this one out. But since this is squared, this is cosine of 2y being squared. My guess is that cosine 2y would be stuck in the square. Okay,
Which
right.
actually would be -2 sine 2.
Okay.
And then you take out, so with that you get rid of sine 2 you put down du, so then you have cosine 2y times u.
Based on these, this looks good. This looks good. When you rewrite this though, I don't know where your integration is. Like I should see you trying to integrate something in terms of u.
So just
Well, this looks like this is u squared to me.
You're starting to think like you're still like 9 you
Are you gonna have stuff so we can check?
On the website, it started to be there.
Okay.
Now they start having stuff about it too.
Do we need
It's good to be able to see, like, try, just because you can do integration, just because you can do new substitution integration, but you can't tell when you use new sub versus not. That's good to do.
It's just 2y over 1 plus 2.
On number 7, did you substitute?
Split it up. Yeah, that's it.
Okay, so on the 2y squared part,
2y squared, that would be 2y to the power of 3 over 2. You're subtracting it. Subtracting 1/2 from 2.
okay, so is your final answer 2/3 y to the 3 over 2 plus 2 times y over 3 over 2?
I don't know what you just said, but yeah, if you did that right, you should.
See, that's what I'm saying. Okay.
Of course, make sure you guys check your answers to this number 94. Those are already up on the website. So before you think you're finished today, make sure there's not any that you're doing incorrectly.
Okay, you're on 5. Wait.
6, right?
Oh. So it's just 1. Did you get 4 times? That's
What? Some of the you know, like I'm doing workshop 1 right now because I missed one. So
Okay. That's almost a week ago.
yeah.
Okay. Let me know if you have questions.
Oh yeah, this is for science too. How do you make one? That's the one.
There's 2. What is
Because we need to cosine to get -2 sine 2x, so that's sine, and then you have to just use that let's call it a day of war. But I think we'll be done. No, because secant and tangent turns into secant. That's the derivative of secant is just secant times tan. Yeah, I mean, yeah, because that's just
Number 9. I'm trying to remember what that is. No. What it is in Mandarin.
what is what?
Mandarin. Jill. 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 Okay. Numeral Jill. Jill. Yell me.
I got 1 for cosine x to the 2 plus.
Well, I don't want your answer. I want to know how I got it, how I get there.
Well, then u is x to the 1/2. Sure. Yeah, just over there.
Okay. But what about this weird little thing over here?
It'll cancel out once you get a du. Like you can see why it cancels out.
Okay. So. What'd you get?
Two signs for this. I mean, square root of x.
Plus C, right?
Yeah, plus c.
Okay, good.
like she walked in somewhere, and then she was okay, but
Second tangent is the derivative of the plus.
and then I just like good luck. And then after that, like I like I can't no, you know about that. You know, you say no, sometimes it just stands out. Or you should do like big books, big chemistry, big books. It hurts. What's happening here?
Yeah, well, it goes up.
But what is it? Is it tangent? Or is it
What is secant squared?
no?
I think that's messed up.
I need to see it. So secant. 1/2. I take what I say. But it's like she's funny.
1/6 cosine of 2y cosine 2y. Yeah, I know. 2y.
Come on, man.
Cosine squared 2y.
Easy. I know.
Variables
That was funny.
Question about this one. Why did it plus this?
Well, based on this, it looks like they're taking the derivative with respect to x. So if you take the derivative of 2x, it just becomes 2. But if you took the derivative of y with respect to x,
It's 0. Because it's constant, right? Constant.
why would y be a constant?
Because it's over the particle derivative of x. So this is constant. I think z is constant too.
Well, the way they're writing, I don't know why the y is disappearing, but right here it looks like they're taking the derivative of z with respect to x, which is what they're writing right there, which implies that z is not a constant.
But it's over the x. Takes the derivative.
Yeah, but where did this dx go from this step to this step? Like I see what you're saying here. You're taking the derivative z with respect to x. It says that here. But then where did the dx go in the next step?
Dx.
Mhm.
So we saw, okay, we saw for this, and I don't understand this step.
Yeah, I know, but that's what I'm saying. Where did this dx go from here to this step?
Here, dx, right?
Okay. This is a weird way to write it, but look, this, I believe this is, they're saying that this is derivative, and it's like they're just factoring it out, kind of. So it's the derivative of 2x with respect to x, which would be what?
2.
Okay, then the derivative of y with respect to x, which I don't know why that's 0.
And y, wait,
It has something to do with,
is from this.
okay, I'd trust you on that. But then this, well, this part, this is saying the derivative of z, it's like you're distributing this. The derivative of z with respect to x. And they didn't know what that was, so they just carried it down. Still the derivative of z with respect to x. It's the same thing as this, it's just that they're distributing it.
But I think the z is constant. It's still gonna be 0.
Well, I don't know the rest of the question to know why, what else is a constant.
So this is the function, and you have to define this.
It could be something to do with, since it's got 3 variables, there might be a part of it in there that I just don't remember, because I haven't had to do this before. We don't have to do this for Cali B. Not with 3 variables like that. You might ask, do you know Miss Cross?
Yeah.
I think this might show up in BC. If you show that to her and show her this step, she might be able to answer it a little bit quicker than me. Because I'm not sure. I'm not sure without revisiting how to do derivatives of 3 different variables. But I think, again, I just don't know why some of those are constant and some of them are not constant. I don't remember that part.
That's so confusing.
Yeah. But you don't have to worry about that for this class, at least. You just studying ahead for next year?
No, for ACTM.
I don't know if that's on ACTM or not. Miss Cross would probably know, though.
With ACTM for the calculus part, it can contain the AB and BC.
And BC, huh?
What about 3 calculus 3? No.
High schools don't offer Cal 3, and ACTM only is on, you can only take the test in the class that you're in. So if they offered a Cal 3 test, no one could take it because no one's enrolled in Cal 3 in high school. You can take Cal 3 through the university while you're in high school, but it's not a high school course. So as far as the ACTM part, I don't know. A lot of students don't
It's gonna
even.
be so hard.
Yeah, a lot of students. Well, I mean, you're trying to do something that you might learn next year, so at the same time that you're learning AB, that's a lot to do at once.
So for BC is just a little bit for BC.
Yeah, so you learn the A and B parts, and in BC you're going to review the B part. So
What is the B part?
some of the stuff we're doing right now?
Is the integrals,
Uh-huh.
but not derivatives.
Well, I mean, even in doing integrals, we still do derivatives in here, right? Like I'm doing this U substitution, I'm taking derivatives here. I'm taking derivatives to check my answers. So you're not specifically learning about derivatives, but you're still using them. And then the C part would be the new part.
Is that hard?
I think the content's a little bit harder than what we have to do, but you have more time to do it.
What's the C part? Do you
Huh?
have, what's the C part like? Do you have?
Series, polar,
Can you write it? Write it.
write the words.
Yeah.
Those are the only two things that I remember. But Ms. Cross teaches BC, so ask her what else besides series and polar shows up in BC. She'll be able to tell you.
Okay.
But you got to understand that people in BC, like, they spent weeks doing this, and they spent weeks doing this, and you're trying to cram it all in. So yeah, it's going to be real hard to do that, but it's good to try.
Wait, is they gonna have Taylor series in the test?
Probably. That's why when you take the ACTM next year, after you've learned that stuff in BC, it's going to be significantly easier.
I waste my
You're-
$5.
Well, I haven't enrolled you yet, so you can still back out. I have to send the money over
No,
like
because my friends are all coming today. Right?
Okay, well. Yeah, Taylor series is a big part of BC. What you got?
What does this mean?
It's just like this. Like if this dx bugs you here, you can put the dx out on the outside. Same thing here. This is like, you could put the square root of x here, and then it's got a dx. It's the same thing. It's kind of a weird way to write it. But
Also, for this one, I couldn't figure out what, because I separated it out into this, and I took the 2 out as well. But what would, like, U be? I tried to make it 2y squared and
I
it
don't
didn't
think
really
I don't think you need to. This is just undoing power rule, because this is like u to the 1/2. So raise the power by 1 divided by the new power.
You mean y to the 1/2?
Yeah, I'm sorry.
Okay.
Yeah. And then over here, I'm not sure about this. 2 minus 1/2 would be 1.5.
Minus? Oh, okay.
Yeah, when you divide things with the same base, you subtract the exponent. Right here, instead of calling this y times y to the 1/2, just call it y to the 3/2.
Okay.
And then you're just undoing power rule there too. So you don't even need U substitution.
Okay.
Really confused how you were helping that was. Accelerate down half of what I'm thinking. Oh, again. Yeah, what? Oh, nothing. That was supposed to
But then you have to do what
I think I finally used the full potential of my brain for the worksheet number 2 because I actually didn't have too much trouble with it.
Good.
Except for these like 2 questions that took me a minute because it's like cosine squared 2y. I'm like, I thought y was a 2y, but I was like, wait a minute, the square is just showing me the u.
Yeah. That's what happens. Eventually you get enough practice and it starts to come a little easier. That's why I've been making y'all practice it so much.
That and it's getting a little bit easier to guess which one is u.
Yeah. Yeah, and that's a hard thing for me to teach you. I can just kind of show you and eventually you kind of catch on, but there's not like a rule to know what you should be.
Yeah, like if you see like a cosine squared and a sine, you're like, wait a minute, those are similar.
Yep.
How do I get that?
Okay, guys, you've got about 5 minutes. So if you are still working and you have homework, please update your planner. If and as you have time to look over and re-practice some questions to prepare for your test would be a good idea. Again, your test is not Wednesday, but it is Friday. So now is the time to start filling in those gaps. You should be well aware of what it is you consider to be your weaknesses.